let's start looking at tests involving proportions. As before, we'll just do the simplest of all proportions tests. And before we start, let's talk about some notation. Alright, the population proportion will be denoted by small p, not capital P. Capital P would be for probability, which is like a similar concept, but we'll separate the two. And the sample proportion we'll call p hat. Actually, statistics, anytime you see a hat over something, it means that whatever is underneath is an estimate. Alright, so p hat is the estimate of p. So the sample proportion is the estimate of the population proportion. From sampling theory, just like the sampling distribution on sample averages x bar, we could have a probability distribution of all possible sample proportions, p hats. The middle of that distribution will be the population proportion p, and standard deviation of that distribution will just be denoted by sigmas of p hat. In other words, the standard deviation of the p hats. The formula for sigmas of p hat is the square root of p, the middle of that distribution, times q, its complement, divided by n. Alright, so remember q, the complement of p, so it's 1 minus p. And actually you could write the formula that way too, sigma of p hat being the square root of p times 1 minus p divided by n. Alright, so this is the notation we have. We'll be using p for the hypothesized value, p hat for the sample value that we'll need from the sample, and we'll calculate sigmas of p hat, which depends on p and not p hat. Okay. Also, what's useful here is to show you that proportion is nothing more than a fancy average. Let's say that you have a small group of people, 5 people. Some are males, some are females. Okay? Let's just go. Next one's a male, next one's a female, female, male, female. Let's talk about the proportion of females in this group. Clearly there's just 3 out of 5. One way to make this become an average is for every female is to put the value 1, and therefore every male put the value 0. So our first one's male, so 0, second female is 1, female 1, male 0, female 1. And you can think of these zeros and ones as x's. And so you add up the x's and you get the number 3. Alright, in our old notation from 214s, that's sigma x. Okay, so you can think of this, we get the average here, the sample average, x bar is sigma x divided by n. Sigma x is 3 divided by the number of items in the samples, 3 out of 5. Alright, 3/5, 0.6. But clearly that's the same as the sample proportion in this group. Which if you wanted notation for it, and it follows the interpretation of the notation as with proportions, binomial distribution, x here would be not these x's per se. X would be the number of successes, in this case the number of females, number of items with a particular quality divided by the number of items in the group, and again you get 3/5 or 0.6, and that works for any proportion. So a sample proportion is nothing more than a very particular kind of sample average. Right? So as before, anything we can do with an average with hypothesis testing or whatever, we can do with proportion.